Projections and coordinate systems. This particular lecture will consist on the topics related with projections, examples of different projections and coordinate systems. First of all, what is meant by projection? To explain on that, the earth is a spheroid. The best model of the earth is a globe, but the drawback of is the globe directly cannot be used for a planimetric measurements because it is not easy to carry, and also the measurement depends upon the distance, area and angle will be difficult with respect to the model of a globe. Hence, we suggest on maps where the model can be mapped easily. So the maps are flat and it is easy to carry and good for measurement scalable. This is one of the picture where a perfect globe is cut into pieces for transforming it into a map. And this is one more example where a perfect globe is carried as a map for mapping the projections. A map projection is a method for mapping spatial patterns on a curved surface, that is the Earth's surface, to a flat surface. So this particular image represents an imaginary light projected onto a developable surface. A variety of different projection models exist. This is one example with respect to a cone, where a cone has developable surface. A cone can be developed into a surface model based upon two types. One is secant cone, the other one is tangent cone. So the conical projection surface area of a cone is displayed in the picture. The one more example of projection of a cylinder as a developable surface is shown in the figure. And this is a plane as a developable surface. So map projections are always introduce error and distortions, but the distortions can be minimized in one or more following properties. So the property number 1 based upon the shape, where a conformal shape will reduce minimized errors. Number 2 is the distance, so equidistant surfaces can reduce errors. And directions, so the direction can be a true direction where a map can be projected. And the area of projection should also be equal in nature. So exactly what are map projections? So map projections are a set of mathematical equations that convert coordinates from one system to the another. For example, an unprojected angles with x and y axis is projected with a function of Cartesian coordinates, say f of x, y. How do projections work on a programmatic level? Each set of coordinates is transformed using a specific projection equation from one system to another. Angular measurements can be converted to Cartesian coordinates, and one set of Cartesian coordinates can be converted to a different measurement framework. It can be either cylindrical or spherical, etc. So this is an example where the table shows a projection model of a geographic picture showing its axis on latitude and longitudinal directions in angular representation. So this particular picture shows that applying a projection to a data frame is like putting on a pair of glasses. This picture resembles that. You can see the different images wearing a pair of glass, which is same, where a map when is projected will be seen differently, but the data is not changed. So geographical projection can be shown as in the figures, that is, a particular area can be projected in a map manner, that is in a planar manner. So for this purpose, we need the introduction of coordinate systems. How a perfect Earth is converted into coordinate systems where its axes are being marked and projected. So coordinate systems. Features on spherical surfaces are not easy to measure. Features on planes are easy to measure and calculate with respect to distance, angle and area. So coordinate systems provide a measurement framework. A coordinate system is a grid used to identify locations on a page or screen that are equivalent to grid locations on the globe. The coordinates are x, y pairs that are based on some universal origin point for reference. The most commonly used is latitude and longitude. The pictorial representation of latitude and longitude refers to degree, minutes and seconds of hour from reference lines that run east-west, that is latitude as equator, or north-south, longitude as prime meridian. This is a few projections of planar, conical and cylindrical surfaces where it is converted to a map projections. This is cylindrical projections, and here different lines are tangential but directions are true in case of normal, transverse and oblique. Regardless of what type of map you make, the representation of the Earth will be distorted in at least one aspect, whereas it may be with respect to shape. Maps that preserve shape are called conformal maps. Aspects with respect to area. Equal area maps preserve the actual amount of the surface area the region takes up on the globe relative to other areas of interest. With respect to distance, equidistance maps preserve distance for all lines that pass through a specified point. With respect to direction, azimuthal maps preserve direction for at least one point on the map, such that all points that pass through that point show true direction. No map can show all four things without distortion, and no map is able to preserve all of the characteristics equally regardless of the type. In any projection, there is no distortion on the line where the globe touches the cone, plane or cylinder. That is, there is always at least one true set of coordinate lines. The orthogonal coordinate systems is classified into three types. One is Cartesian, which is called as rectangular coordinate system. Number 2, cylindrical coordinate system. Number 3, spherical coordinate system. So the graphical representation of Cartesian coordinate system consists of x, y and z planes. The unit vectors of along x direction is represented as ax, unit vectors or unit directions along y direction is represented as ay, and the unit directions or unit vectors along z direction is represented as az. In cylindrical coordinate system, we represent the coordinate axis as r, phi and z. R will make the radius of the cylinder, and phi makes azimuthal angle with respect to the plane xy, and z is a parallel plane along z direction. And the differential areas and volume with respect to the cylindrical coordinate system is as shown in the figure. Spherical coordinate system. Spherical coordinate system consists of a sphere in the xyz plane making an cone with respect to z plane. And the axes of spherical coordinate systems are r, theta and phi. R is the radius of the sphere and theta is the half angle with respect to the cone, and phi is azimuthal angle which is parallel to the plane xy. Thank you.